Number 16. A ductile metal wire has resistance big R. What will be the resistance of this wire in terms of big R if it's stretched to 3 times its original length, assuming that the density and resistivity of the material do not change when the wire is stretched? Hint, the amount of metal does not change, so stretching out the wire will affect its cross-sectional area. Okay, so the important thing here, we're asking about the resistivity. And it tells us that we have the density remaining the same, and then we're changing the length and the area. So we're going to want to use our resistivity equation, which is our rho L over A. So this is our resistance, this is our density of the material, the length of the material, and the cross-sectional area. So when we start, we have this resistance, R. Density stays the same. Sweet. So now we take L and we pull it out to 3 times its original length. And we want to know how is that going to affect A, and therefore how is that going to affect R. So let's assume a circular cross-section. So then the volume of my wire when I start with is pi r squared times L. And then afterwards, we have pi, let's use m, pi m squared times 3L. So how is the radius of our cross-section going to change? So the volume has to stay the same, which is why we set these equal to each other. My pi's cancel out, my l's cancel out. So r squared is equal to 3m squared. So m squared is equal to r squared over 3. So my initial resistance, that was rho L over pi little r squared, is now rho 3L over pi little r squared over 3. You see what I did there? So now we have our rho L, we have our pi r squared, but we have a 3 on top, and we have a 3 on the bottom of the bottom. So that's as if that's up here. So this is actually increasing the resistivity by a factor of 9.